Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 77 from the Smith Organic Chemistry textbook. This problem says reaction of oxetane with methyl magnesium bromide followed by water forms a compound that shows a strong absorption in its IR spectrum at 3600 to 3200. And then we're given NMR data and asked to draw the structure of the product and to write a mechanism that illustrates the product's formation. Okay, and so the first thing to do here is to look at this IR, and hopefully we know by now an IR peak between 32 and 3600 is going to be from an alcohol, from an OH. So we have an alcohol in this molecule. Okay, and then looking at the NMR data, so we have a 0.94 ppm triplet that integrates to 3. So that is going to be a methyl group next to a methylene group. Our next signal is a multiplet that integrates to 2. So this is a methylene. The next signal also integrates to 2. This is also probably a methylene group. We have a singlet that integrates to 1 at 2.24 ppm. So I'm going to tentatively say that this is the hydrogen on our alcohol. And then we have a 3.63 ppm triplet that integrates to 2. So this is another methylene. And I'm going to say that this is the methylene that is bound to the alcohol. And that's why it's so far downfield, because it's deshielded by the alcohol. And so looking at these 5 signals that we have, I'm going to say that the structure of our product is this. So 1-butanol. And then as far as a mechanism that illustrates its formation, I'll do that over here on the left. It's a pretty straightforward mechanism. So we have the oxetane, the methyl magnesium bromide is going to act as a nucleophile and add to the carbon that's bound to the oxygen here. The carbon-oxygen bond will break, and those electrons will go to the oxygen. And so after that first step, we're here with the alkoxide. Oops. And so there is, of course, a negative charge here. And then the water, the quenching step, is just going to protonate that alkoxide that we just made. So rather than try to squeeze it in right there, I'll put it down here. Okay, and so there we go. There's the mechanism that accounts for this product. As I said, is a pretty straightforward mechanism. And that's the answer to Chapter 20, problem number 77.